And now in this lecture we'll find out the radius of a circle. In the drawing we have a circle. Inside this circle we have chord dB. Chord dB equals to 2 units in its length. And we also have chord AC. Chord AC equals to the square root of 2 units. This is angle DEB. The size of angle DEB is 45 degrees. Again, our mission is to find out the radius of this circle. So first of all, we'll add points A and D together by a straight line. By joining points A and D, we created a peripheral angle BAD. This is peripheral angle BAD. We will define the size of this peripheral angle BAD as x over 2. So this is peripheral angle BAD. And this peripheral angle BAD is subtended on chord BD. Repeat again. Peripheral angle BAD is subtended on chord BD. In the next step, we will define the center of this circle. This point is point O. And we will join points O and D together by a straight line. Likewise, we will join points D and B we will join points O and B together by a straight line. By doing this construction, we created here central angle BOD. This is central angle BOD, and this central angle BOD is also subtended on the same chord called BD, exactly like this peripheral angle BAD. This is subtended on the same chord called BD. So now we can implement here rule 13. I'll repeat quickly on rule 13. According to rule 13, a central angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle. Inside this circle we have peripheral angle ACB. This is peripheral angle ACB. The size of this peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. In addition, we have here central angle AOB. This is central angle AOB that is also subtended on the same chord called AB. And according to this rule 13, the size of the central angle AOB, this central angle AOB, is twice as large as the size of this peripheral angle ACB. The size of this peripheral angle ACB is theta, and therefore the size of this central angle AOB must be 2 theta. Okay, So we can actually implement Rule 13 in our drawing. Why? Because in our drawing those two angles they are both subtended on chord BD. The size of this peripheral angle DAB is x over 2, therefore the size of this central angle DOB must be equal to x over 2 times 2, that is x. Okay. Repeat again. The size of this peripheral angle DAB is x over 2, therefore the size of this central angle DOB that is subtended on the same chord called DB must be equal to x over 2 times 2, that is x. Likewise, we will define the size of this peripheral angle ADC, this angle as y over 2 degrees. In the next step, we join points O and C together by straight line. We join points O and A together by straight line. By doing this construction, we enter the center angle AOC. This is center angle AOC, and this center angle AOC is subtended on the same chord called AC, exactly like this peripheral angle ADC. This is also subtended on the same chord called AC, and therefore, according to Rule 13, the size of this peripheral angle AOC must be twice as large as the size of this peripheral angle ADC. Why? Because both of those two angles they are both subtended on the same chord called AC. The size of this peripheral angle ADC is y over 2, and therefore the size of this center angle AOC must be equal to y over 2 times 2, that is y, according to Rule 13. I follow the fact that the size of the central angle is twice as large as the size of the peripheral angle that is subtended on the same chord. The size of this central angle and peripheral angle is y over 2, and therefore the size of this central angle AOC must be equal to y over 2 times 2, that is y, according to Rule 13. Okay, so in the next step, I'll copy the green triangle DAE, this green triangle DAE in a new page, and we'll implement Rule 4 in this green triangle DAE. So actually, this is triangle DAE that according to the original drawing. Inside this triangle DAE, we have three angles, x over 2, y over 2, and this is angle DEA. All those three angles are defined as the interior angles of this triangle DEA. Why? Because of the fact that all those three angles are located inside triangle DEA. So I write it down. So this is angle EAD, this is angle EDA, and this is angle DEA. All those three angles are defined as the interior angles of this triangle DEA. While this is angle BED, angle BED is located outside. Angle BED is located outside triangle DEA, and therefore it is defined as the external angle of this triangle BED. So write it down. This is the external angle of this triangle DEA, because this is located outside triangle DEA. So in the next step, I will present to you rule 4, and we will implement rule 4 in our drawing. According to rule 4, the exterior angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing, we have a triangle. Inside this triangle, we have three angles, A, B, and C. All those three angles are defined as the interior angles of this triangle, because they are located inside the triangle. While this is angle E, it is located outside this triangle, and therefore it is defined as the exterior angle of this triangle. And according to this rule 4, the size of the external angle E is equal to the sum of the two interior angles that are not adjacent to it. This is angle C. Angle C is adjacent to angle E. The two other interior angles that are not adjacent to angle E are A and B. So according to this rule 4, the size of the external angle E is equal to the sum of the two interior angles that are not adjacent to it. That is to say, angle E equals to A plus B. Okay, the size of the external angle E is equal to A plus B. A and B are the two interior angles that are not adjacent to angle E, and therefore the size of angle E is A plus B. So we can actually implement rule 4 in our drawing. Why? Because in our drawing we have here triangle EDA. This is angle DEB. Angle DEB is the external angle of this triangle DEA. And according to rule 4, the size of the external angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is angle DEA that is adjacent to this angle BED, and the two other interior angles that are not adjacent to it are x over 2 and y over 2. So the size of the external angle BED is equal to x over 2 plus y over 2. So write it down. According to rule 4, the size of the external angle BED is equals to the sum of the two triangles that are not adjacent to it. That is to say, it is equals to x over 2 plus y over 2. According to rule 4. But it is given us in the question that the side of the triangle BED is 45 degrees. So we can solve the angle BED by 45 degrees. So 45 degrees equals to x over 2 plus y over 2. According to rule 4. So here we multiply this equation by 2. And finally we get that 45 degrees times 2 is 90 degrees. And 90 degrees equals to x over 2 times 2, that is x, plus y over 2 times 2, that is y. So if we found out that x plus y equals to 90 degrees, here we subtract x from this equation, and finally we get that y equals to 90 degrees minus x. Okay. In the next step, I will present to you the law of cosines. Actually, I'll repeat on the law of cosines, and we will implement the law of cosines in this triangle BOD, and in this triangle OCA. So, I'll repeat quickly on the law of cosines. Actually, the law of cosines is true in any triangle. So this is triangle ABC that could be any triangle. In this triangle ABC, the length of side AB is A, side AC equals to B units in its length, and this is side BC is equals to C units in its length. This is angle BAC, the side of angle BAC is theta. So according to this law, the law of cosines, the following in this triangle ABC that could be any triangle, the following equation is true. That cosine theta equals to a square plus b square minus c square over 2 times a times b. Again, cosine theta equals to a square plus b square minus c square over 2 times a times b. So we can actually implement the law of cosines in any triangle, and therefore we can actually implement the law of cosines in this triangle BOD. So I'll copy this triangle BOD in a new page, and we'll implement the law of cosines in this triangle BOD. Side DB equals to 2 units in this graph, according to what is given as the question. What is the length of side BO? Point O is the center of the circle. point B is the point on the circle itself, therefore OB is the radius of this circle. The radius of the circle is the radius that we are looking for in this question. So we define the radius of this circle as R, therefore OB equals to R. OD also equals to R. OC equals to R. And OA also equals to R. So say this is triangle DOB, the copy from the original drawing. According to the law of cosines, in this triangle DOB, cosine x will be equal to DO square plus OB square minus DB square over 2 times DO times OB again. Cosine x will be equal to DO square plus OB square minus DB square over 2 times DO times OB. So I write it down. So according to the law of cosines, cosine x will be equal to DO square. DO equals to R, therefore DO square is R square plus OB square. OB also equals to R, therefore OB square is R square. So it is plus R square minus DB square. DB equals to 2, therefore DB square is 2 squared, that is 4. So it is minus 4 divided by 2 times DO. DO is R, therefore it's also DO by R times OB. OB is also R, so it's also OB by R. So if we found out that according to equation 1, cosine x equals to R square plus R square minus 4 over 2 times R. R square plus R square is 2R square. So in total, the numerator of this expression we have 2R square minus 4 divided by 2 times R, that is 2R square. So here we have 2R square over 2R square is 1, and we have also minus 4 over 2R square. So cosine x equals to 1 minus 4 over 2R square. Here we divide this expression, both the numerator and the denominator of this expression by 2. And we get that minus 4 over 2 is minus 2, and 2R square over 2 is R square. So in conclusion, we found out that according to equation 1, cosine x equals to 1 minus 2 over R square. Okay, again, if we found out that according to equation 1, cosine x equals to 1 minus 2 over R square. But we have already found out that y equals to 90 degrees minus x. So if we found out that that y equals to before that I'll copy this triangle AOC in Olympiad, and we will implement the law of cosines in this triangle AOC. Side AC equals to the square root of 2 units left, according to what is given as the question. Side AO equals to R, and side CO also equals to R. Actually, this is triangle AOC that according to the original drawing, and this is of course angle Y, angle AOC is Y, angle Y. So in the next step, we'll implement the law of cosines in this triangle AOC. So according to the law of cosines, this triangle AOC, cosine Y will be equal to AO square. AO is R, therefore AO square is R square, plus OC square. OC is also R, therefore OC square is R square, so it is plus R square minus AC square. AC is square root of 2, therefore AC square is square root of 2 squared, that is 2, so it is minus 2 divided by 2 times AO is R, times OC is also R. So in conclusion, we can find out that according to equation 2, cosine Y equals to R squared plus R squared minus 2 over 2 times R times R. R squared plus R squared is 2R squared. So in total, in the numerator of this expression, we have 2R squared minus 2 divided by 2 times R, that is 2R squared. So cosine Y equals to 2R squared over 2R squared is 1. We have here minus 2 over 2R squared. So in conclusion, we can find out that cosine Y equals to 1 minus 2 over 2R squared. So it is equals to 1, and here we divide both the numerator and the denominator of this expression by 2, and you get that minus 2 over 2 is minus 1, and we have 2R squared over 2 is R squared. So if we found out that According to equation 2, cosine y equals to 1 minus 1 over r squared. This is according to equation 2. But we already found out that y equals to 19 raised minus 6. So y equals to 19 raised minus 6. So now we can substitute y in this equation 2, y 19 raised minus 6. We do it now and we get that according to equation 2 we have cosine y, so it is cosine y and y is 19 raised minus 6 equals to 1 minus 1 over r squared. So, after we found out that cosine 19 raised minus 6 equals to 1 minus 1 over r squared. We have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus x. So according to this trigonometric identity, we can substitute cosine 90 degrees minus x in this equation 2 by sinus x. We do it now and we get that. So cosine 90 degrees minus x is sinus x, and sinus x, according to equation 2, sinus x equals to 1 minus 1 over r squared. So repeat again, according to equation 2, we actually found out that sinus x equals to 1 minus 1 over r squared. This is according to equation 2. When according to equation 1, we have already found out that cosine x equals to 1 minus 2 over r squared. Because again, according to equation 1, cosine x equals to 1 minus 2 over r squared. So we have the values of sinus x and cosine x in terms of r. R is the radius that we are looking for in this question. And the next step, we use the trigonometric identity that states that sinus square x plus cosine square ax equals to 1. According to equation 2, sinus x equals to 1 minus 1 over r squared. Again, sinus x according to this equation 2 equals to 1 minus 1 over r squared. If sinus x equals to 1 minus 1 over r squared, it means that sinus square x will be equal to 1 minus 1 over r squared. So this will be equation 3. So this is sine of square x plus cosine square x. According to equation 1, cosine x equals to 1 minus 2 over r squared, and therefore cosine square x will be equal to 1 minus 2 over r squared. So this expression 1 minus 2 over r squared is cosine square x. And according to this trigonometric identity, sine of square x plus cosine square x equals to 1. So this expression equals to 1 according to this trigonometric identity. So in conclusion, if we found out that 1 minus 1 over r squared plus 1 minus 2 over r squared equals to 1. We define t as 1 over r squared. That is to say, according to our definition, t equals to 1 over r squared. In the next step, we substitute 1 over r squared in this equation 3 by t. We do it now, and we get that according to this equation 3, we have here 1 minus 1 over r squared, and 1 over r squared is t according to our definition, so we substitute 1 over r squared by t. So in total, this expression will be equal to 1 minus t squared, and we have also here 1 minus 2 over r squared. Here we multiply this equation by 1. Actually, it is allowable to multiply an expression by 1, because by multiplying the expression by 1, you will not change the value of the expression. So we have here 1 minus 2 times 1 over r squared, and 1 over r squared is t, so we substitute 1 over r squared by t. So in total, this expression will be equal to 1 minus 2t squared, and it equals to 1. So in conclusion, according to equation 3, we actually found out that 1 minus t squared plus 1 minus 2t squared equals to 1. Here we'll open the brackets on this side of this equation 3, and finally get that according to this equation 3, we'll have here 1 minus t squared. 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t, and we have also here 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared. 2t squared is 4t squared, so this plus 4t squared, minus 2 times 1 times 2t, that is minus 4t, that equals to 1. So here we have 1 on both sides of the equation, so 1 we get cancelled. After we cancelled 1, in this side of equation 3, we have this equation 3, we have t squared plus 4t squared is 5t squared, and we have also minus 2t minus 4t is minus 6t, plus 1 equals to 0. In conclusion, we actually found out that according to equation 3, t squared minus 6t plus 1 equals to 0. So this is a quadratic equation, and the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that we are looking for. And we find out the value of x according to the following formula. X equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Now specific quadratic equation, that is to say 5t minus 6t plus 1 equals to 0. The variable that we're looking for is t, so x equals to t. The coefficient a equals to 5. The coefficient b equals to minus 6. And finally, the coefficient c equals to 1. So the only thing that is left to do is to put this data for our specific quadratic equation inside this general formula for x, and in this way we find out the value or the values of t, because x equals to t. So we do it now, and we get here that x equals to t, so we substitute x by t, and it is equals to minus b. B is minus 6, therefore minus b is minus 6, that is plus 6, plus minus square root of b squared. B is minus 6, therefore b squared is minus 6 squared, that is 36. Minus 4 times a. A is 5, so minus 4 times 5 is minus 20. Times c. C is 1, so minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. A is 5, so 2 times a is 2 times 5, that is 10. So I found out that c equals to 6 plus minus. Inside the root we have 36 minus 20, that is 16. So inside the root we have to only have 16 divided by 10. So actually found out that t equals to 6 plus minus, the square root of 16 is 4 divided by 10. So again, I found out that t equals to 6 plus minus 4 over 10. So here we have two solutions for t. The first solution for t is that t equals to 6 plus 4 over 10. So t equals to 6 plus 4, that is 10, and 10 over 10 is 1. So we found out that the first solution for t is that t equals to 1 for one side, but from the other side, according to our definition, t also equals to 1 over r squared. So here you can substitute t in this equation by 1 over r squared. We do it now, we get that 1 over r squared equals to 1. So here we multiply this equation by r squared, and finally get that r squared equals to 1. I found out actually that r squared equals to 1. So here we take a root out of this equation, and finally get that the radius r that we are looking for, that is the radius of this circle, is equals to the square root of 1, that is 1. Again, if we found out that the radius of this circle r equals to 1 unit. But it is actually impossible that the radius r of this circle will be equal to 1. Why? Because we know that chord dB equals to 2 units in its length. It is given us in the question that chord dB is equals to 2 units in its length. And it is very easy to see in the drawing that chord dB is not the diameter of the circle. Again, chord dB is definitely not the diameter of this circle. So I write it down. Chord dB is not the diameter of the circle. Chord dB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. So what is the diameter of this circle? The diameter of this circle is of course 2r. Okay? So the diameter of our circle is 2r. And 2r is the longest chord in the circle. Therefore 2r must be greater than dB, that is not the diameter of the circle. Again, 2r must be greater than chord dB, that is not the diameter of the circle. And dB equals to 2, according to what is given in the question. So we can write here that dB equals to 2. And from this equation, 2r greater than dB equals 2r is greater than dB, that equals to 2. We derive that 2r is greater than 2. Okay? 2r is greater than 2. When we divide this inequality by 2, and finally we get that the radius r that we are looking for must be greater than 1. So I shall found out that the radius r of this circle must be greater than 1. If the radius r of this circle must be greater than 1, the radius r cannot be equal to 1. So we cancel the solution, and we take into account only the second solution for t. Because the first solution for t, that is t equals to 1, give us a contradiction. And therefore we take into account only the second solution for t. The second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So we actually found out that the second solution for t is that t equals to 1/5 from one side, but from the other side, according to our definition, t also equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We do it now, we get that 1 over r squared equals to 1/5. Here we cross multiply this equation, and finally we get that r equals to 5. Here we take out of this equation, and finally we get that r, that is the radius of this circle, that is the radius that you are looking for in this question. R equals to either the square root of 5 units in its length, or in terms of numbers, R equals to 2.236 units. And again, we should find out that the radius R of this circle is equals to either the square root of 5 units in its length, or in terms of numbers, R equals to 2.236 units. Okay, so in the next step, I'll summarize the lecture. In this lecture, I found out the radius of this circle. So in the drawing we have a circle. We have also called DB. This is equals to 2 units in itself. This is called AC. The length of code AC is code of 2 units. This is angle BED. The size of angle BED is 45 degrees. Again, our mission is to find out the radius of this circle. So, first of all, in the first step, we join points A and D together by a straight line. Again, we join points A and D together by a straight line. We join points A and D, okay, that is peripheral angle DAB. This is peripheral angle DAB. We define the size of this peripheral angle BAD as x over 2. It is very easy to see that peripheral angle DAB is subtended on chord DB. Again, peripheral angle DAB is subtended on chord DB. In the next step, we define the center of this circle. This point is point O. And then we join points O and D together by a straight line, and we join points O and B together by a straight line. By doing this construction, we created the straight triangle DOB. This is straight triangle DOB, and this straight triangle DOB is subtended on the same chord called DB, exactly like this. Peripheral angle DAB, this is also subtended on the same chord called DB. So now we can implement all 13 in our drawing. So repeat quickly on all 13. According to all 13, a certain angle is twice as large as the peripheral angle subtended on the same chord. So in the drawing we have a circle, and we have also, this is peripheral angle ACB. The size of this peripheral angle ACB is theta, and this peripheral angle ACB is subtended on chord AB. Likewise, we have also here third triangle AOB. This is third angle AOB, and this third angle AOB is subtended on the same chord called AB. So because of the fact that those two angles are both subtended on the same chord called AB, the size of this third triangle AOB will be twice as large as the size of this peripheral angle ACB. The size of this peripheral angle ACB is theta, and therefore the size of this third triangle AOB that is subtended on the same chord called AB will be equal to 2 theta. So we can actually implement all 13 in our drawing. Right, because in our drawing we have those two angles. They are both subtended on the same chord called DB. The size of this peripheral angle is x over 2, and therefore the size of this third angle DOB that is subtended on the same chord called DB must be equal to x over 2 times 2, that is x, according to rule 13. In the next step, we define the size of this peripheral angle ADC. This angle is y over 2. Again, the size of peripheral angle ACDA is y over 2 according to our definition. In the next step, we join points 1 and 2 together by straight line and join points 1 and 3 together by straight line. By doing this construction, we're going to do straight angle COA. This is straight angle COA. This straight angle COA is subtended on chord CA, exactly like this. Peripheral angle CACDA, this is also subtended on the same chord CA. So those two angles are both subtended on the same chord CA. The size of this peripheral angle ADC is y over 2, and therefore the size of this central angle AOC that is subtended on the same chord CA must be equal to y over 2 times 2, that is y, according to Rule 13. So the size of this peripheral angle AOC must be equal to y over 2 times y, that is y. Okay, so in the next step I copied the green triangle ADE in new page and implemented Rule 4 in this green triangle ADE. Okay, this is the green triangle DEA, this is the point from the original drawing. Inside this triangle DEA we have three angles. This is angle DEA, this is angle EDA. The size of this angle EDA is y over 2, and the size of this angle EAD is x over 2. So all those three angles are located inside this triangle DEA, and therefore they are defined as the interior angles of this triangle DEA. While this is angle BAD that is located outside this triangle DEA, and therefore it is defined as the external angle of this triangle DEA. Okay, and in the next step I actually presented to you Rule 4 and implemented Rule 4 in this triangle DEA. So I'll click here on Rule 4. According to Rule 4, the external angle of a triangle is equal to the sum of the two interior angles that are not adjacent to it. So in the drawing we have a triangle. Inside this triangle we have three angles, A, B and C, and therefore all those three angles are defined as the interior angles in this triangle, while this is angle E, it is located outside this triangle, and therefore this angle E is defined as the external angle of this triangle. According to this Rule 4, the size of the external angle E, this angle E, is equal to the sum of the two angles that are not adjacent to it. This is angle C, that is adjacent to angle E. The two other interior angles that are not adjacent to it, to angle E, are A and B. And therefore, according to this Rule 4, the size of angle E equals to A plus B. That is the sum of the two interior angles that are not adjacent to angle E. So, in conclusion, we found out that according to this Rule 4, the size of the external angle E, angle E, it is equal to A plus B. Again, angle E, the external angle E of this triangle equals to A plus B. That is the sum of the two interior angles that are not adjacent to it. So angle E equals to A plus B. So we can actually implement Rule 4 in our drawing. Why? Because in our drawing we have, this is the external angle BED, and according to Rule 4, the size of the external angle BED is equal to the sum of the two interior angles that are not adjacent to it. This is angle DEA that is adjacent to this angle BED, and the two other angles that are not adjacent to it are those two angles, and the sum of those two angles is x over 2 plus y over 2. So in conclusion, actually found out that according to rule 4, the size of the external angle BED equals to x over 2 plus y over 2. Again, the size of the external angle BED is equals to the sum of the two interangles that are not adjacent to it. That is to say, it is x over 2 plus y over 2. Okay, angle BED equals to 45 degrees according to what is given as the question. So we substitute angle BED by 45 degrees and finally found out that 45 degrees equals to x over 2 plus y over 2. Here we multiply this equation by 2 and finally found out that 45 degrees times 2 is 90 degrees, x over 2 times 2 is x, plus y over 2 times 2 is y. So in conclusion, we actually found out that 90 degrees equals to x plus y. Here we substitute x from this equation and finally found out that the size of angle y is 90 degrees minus x. So y equals to 90 degrees minus x. In the next step, I present again on the law of cosines and implemented the law of cosines in this triangle AOC, in this triangle DOB. So according to the law of cosines, first of all, the law of cosines is true in any triangle. So this is triangle ABC that could be any triangle. This triangle ABC, the length of side AB is A, side AC equals to B units in its length, and side BC equals to C units in its length. This is angle BAC, the size of angle BAC is theta. So in this triangle ABC that could be any triangle, the following equation is true. That cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. Again, cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. You can implement this law, the law of cosines, in any triangle, and therefore you can implement the law of cosines in this triangle, triangle DOB. So copy this triangle DOB in a new page and implement the law of cosines in this triangle, triangle DOB. But before that, we know that OB equals to OD equals to OA equals to OC. All those four line segments are the area of this circle. We define the radius of this circle as R. Therefore, each of these four line segments is equal to R. It is the radius of the circle. The radius of the circle is the radius that we're looking for in this question. Okay. This is triangle DOB that I copied from the original domain. Side DB equals to 2 units in its length, according to what is given in the question. Side DO equals to side BO. They are both the area of the circle. That is equals to 1 according to our definition. So in this triangle DOB, cosine x equals to DO squared. DO is R, therefore DO squared is R squared, plus OB squared. OB is also R, therefore OB squared is R squared, minus DB squared. DB is 2, therefore DB squared is 2 squared, that is 4. So in total, in the numerator of this expression, we have R squared plus R squared minus 4 over 2 times OD, that is R, times OB, that is also R. So in total, in the numerator of this expression, we have 2 times R times R. So in conclusion, according to equation 1, we can find out that R squared plus R squared minus 4 equals to 2 times R times R. R squared plus R squared is 2R squared, so in total, in the numerator, we have 2R squared minus 4 over 2 times R, that is 2R squared. 2R squared over 2R squared is 1, and we have also here minus 4 over 2R squared. So according to equation 1, cosine x equals to 1, and here we divided both in the numerator and the denominator of this expression by 2. And found out actually that minus 4 over 2 is minus 2, and 2R squared over 2 is R squared. So in total, we found out that according to equation 1, cosine x equals to 1 minus 2 over R squared. In the next step, I copied this triangle AOC in a new page and implemented the law of cosines in this triangle AOC. So finally this is triangle AOC that are going from the original line. Side A is equals to the square root of 2 units in itself, according to what is equal to the equation. OC equals to OA, they are both near the area of the circle, that is equals to R, and therefore they are equal to each other. The radius of the circle is the radius that we are looking for in this question. So according to the law of cosines, in this triangle AOC, cosine y equals to OA square. OA is R, therefore OA square is R square, plus OC square. OC is also R, therefore OC square is R square, minus AC square. AC is square root of 2, therefore AC square is square root of 2 squared, that is 2, so it is minus 2. So in total, in the numerator of this expression, we have R square plus R square minus 2, divided by 2 times OA, that is R, times OC, that is also R. So in the denominator, we have 2 times R times R. So conclusion, we found out that according to the law of cosine, in this triangle AOC, cosine y equals to R square plus R square is 2R square. So in total, in the numerator of this expression, we have 2 times R over 2 over 2R square. 2R square over 2R square is 1, and we also have minus 2 over 2R square. So cosine y equals to 1 minus 2 over 2R square. Here we divided both the numerator and the denominator of this expression by 2, and we found out that cosine y equals to 1, and here we have minus 2 over 2 is minus 1, and 2R square over 2 is R square. So in total, actually, we found out that according to equation 2, cosine y equals to 1 minus 1 over R square. This is according to equation 2. Well, in the beginning of the lecture, we actually found out that y equals to 90 degrees minus 6. So we can substitute y in this equation 2, by 90 degrees minus 6. We did it, and we actually found out that so cosine y is cosine 90 degrees minus 6, and it is equals to 1 minus 1 over R square. We have the trigonometric identity that states that sinus x equals to cosine 90 degrees minus 6. So now we can substitute cosine 90 degrees minus 6 in this equation 2 by sinus x. We did it, and also found out again that cosine 90 degrees minus 6 is sinus x according to this trigonometric identity. So sinus x equals to 1 minus 1 over R square. This is according to equation 2, and according to equation 1, we have already found out that cosine x equals to 1 minus 2 over R square. So we have the values of sinus x and cosine x in terms of R. Okay, now we use the trigonometric identity that said that sinus square x plus cosine square x equals to 1. According to this trigonometric identity, we have sinus x equals to 1 minus 1 over R square. If sinus x equals to 1 minus 1 over R square, it means that sinus square x will be equal to 1 minus 1 over R square squared plus cosine square x. According to equation 1, cosine x equals to 1 minus 2 over R square, and therefore cosine square x will be equal to 1 minus 2 over R square squared. And so sin square x is 1 minus 1 over R square squared, and cosine square x is 1 minus 2 over R square squared, and it is equals to 1. In the next step, we defined t as 1 over R square, and then we substituted 1 over R square in this equation 3 by t. And we actually found out that 1 minus 1 over R square, and 1 over R square is t. Therefore, in total, this expression will be equal to 1 minus t squared plus 1 minus 2 over R, 1 minus 2 times 1 over R square. So it is 1 minus 2, and 1 over R square is t. So in total, this expression equals to 1 minus 2t squared, and it is equals to 1. So in conclusion, according to equation 3, we should find out that 1 minus t squared plus 1 minus 2t squared equals to 1. So here we open the brackets on this side of this equation, equation 3, we actually found out that 1 minus t squared equals to 1 squared, that is 1, plus t squared minus 2t, and we also plus 1 minus 2t squared. 1 minus 2t squared equals to 1 squared, that is 1, plus 2t squared. 2t squared is 4t squared, and we also minus 2 times 1 times 2t, that is minus 4t, and it is equals to 1. So here we have 1 on both sides of the equation, so 1 we get cancelled, after we cancelled 1, we left only with here t squared plus 4t squared is 5t squared, and we have also minus 2t minus 4t is minus 6t, plus 1 equals to 0. So she found out that five t squared minus 6t plus 1 equals to 0. So this is the quadratic equation, and then the general formula for a quadratic equation is ax squared plus bx plus c equals to 0. In this general formula, a, b, and c are the coefficients of this quadratic equation, and x is the variable that you are looking for. And we find out the value of x according to the following formula: x equals to 1 of b plus minus 4 of b squared minus 4 times ac over 2a. Now a specific quadratic equation, that is to say 5t squared minus 6t plus 1 equals to 0. The variable that you are looking for is t. So x equals to t, the coefficient a equals to 5, the coefficient b equals to minus 6, and finally the coefficient c equals to 1. The only thing that is left to do is to put this data for our specific quadratic equation inside this general formula for x, and in this way we find out the value of the values of t, because x equals to t. We did it, and we know that x equals to t, so we substitute x by t, so x equals to minus b. b is minus 6, therefore minus b is minus 6, that is plus 6, plus minus, square root of b squared. b is minus 6, therefore b squared is minus 6 squared, that is 36, minus 4 times a. a is 5, so minus 4 times 5 is minus 20 times c. And minus 20 and c is 1, so minus 20 times 1 is minus 20. So inside the root we have 36 minus 20 divided by 2a. a is 5, so 2 times a is 2 times 5, that is 10. So she found out that t equals to 6 plus minus, square root of 36 minus 20 over 10. 36 minus 20 is 16. So she found out that t equals to 6 plus minus, inside the root we have to leave with 16 over 10. The square root of 16 is 4. So in total she found out that t equals to 6 plus minus 4 over 10. So here we have two solutions that are possible for t. The first solution for t is that t equals to 6 plus 4 over 10. 6 plus 4 is 10, and 10 over 10 is 1. So the first solution for t is that t equals to 1. From one side, but from the other side, according to our definition, t also equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We did it, and we found out that 1 over r squared equals to 1. Here we multiply this equation by r squared, and finally found out that r squared equals to 1. Here we took out of this equation, and finally found out that the radius r of the circle equals to the square root of 1, that is 1. So we found out that the radius r of this circle is equals to 1. But it is actually impossible that the radius r of this circle will be equal to 1. Why? Because of the fact that we know that chord dB equals to 2 units in its length. Chord dB equals to 2 units, and chord dB is definitely not the diameter of the circle. Again, from the drawing it is very easy to see that chord dB is definitely not the diameter of the circle. So we can write here that chord dB is not the diameter of the circle. And we also know that the diameter of any circle is the longest chord in the circle. Again, the diameter of any circle is the longest chord in the circle. What is the diameter of this circle? The diameter of this circle is of course 2r. So the diameter of our circle, that is 2r, is the longest chord in the circle, and therefore it must be greater than dB is not the diameter of the circle. Again, the diameter of our circle is the longest chord in the circle, Therefore, it must be greater than dB that is not the diameter of the second, and dB equals to 2. And from this equation, 2r is greater than dB that equals to 2. We derive that 2r is greater than 2. Here we divided this inequality by 2, and we found out that the radius r of our circle must be greater than 1. If the radius r must be greater than 1, the radius r cannot be equal to 1. Therefore, the first solution for t is the correct solution, and therefore we take into account only the second solution for t. And the second solution for t is that t equals to 6 minus 4 over 10. 6 minus 4 is 2, and 2 over 10 is 1/5. So the second solution for t is that t equals to 1/5. For one side, but from the other side, according to our definition, t also equals to 1 over r squared. So now we can substitute t in this equation by 1 over r squared. We did it, and found out that 1 over r squared equals to 1/5. Of course, multiply this equation, and finally found out that r squared equals to 5. We took out of the equation, and finally found out that the radius r of this circle is equals to either the square root of 5 units in its length, or the radius r equals to 2.236 units. Okay, thank you very much.